So good morning to all of you.
Good morning, sir.
Now this is the last day and perhaps the last session and probably the last technical session. I'm very sure you would be counting down, and in between naturally you could be more tensed because there is some assessment also, some test also. Well, then that should not be a big botheration to all of you, because basically all of you are good teachers, and therefore you must have experienced whatever has happened over these 5 days, and therefore with that experience you should be able to answer this so-called test, which should not be a big issue. Test has got to be a byproduct, and the happening of a test is just that it shall happen. Not too much of attention should be paid to such a thing. But then what is important is the day up to the test is more important. In fact, the definition for examination or test is like that only. Test or examination is not on the day of test or not on the day of examination, but it is up to the day of the test and up to the day of examination. So the way with which you would be associated with your studies and with your learning are more important. So learning is more important. That is what is very necessary. So it is not memorizing. So earlier part of artificial intelligence, when we were all beginners, our algorithms in artificial intelligence were memorizing algorithms. They were rule-based algorithms. So the memory, the basic instinct of learning, which we thought is memorizing, was also extended in the domain of artificial intelligence. So we had all if-then rules, and if-then rules became the expert system and became the basis of artificial intelligence in those days. But then artificial intelligence purpose is entirely different. The whole purpose of artificial intelligence, by this time you must have already made it up, that it is the ability to simulate the human intelligence, to simulate the human response given a situation. All right. And in other words, the ability of adapting the learning mechanism, which has been very successfully the basis in any human being. That is what is the most important part of it here. Therefore comes the next stage, the machine learning. Before machine learning, your workshop also has one more title called deep learning. So deep learning and machine learning. So one aspect is deep learning, another aspect is machine learning. There is a very interesting difference between deep learning and machine learning. See, deep learning is associated with the extraction of data and extraction of advanced data, advanced information about any entity, about any object, about any happening, about any event, whatever it is, it is going to be the extraction of, or it is going to be the advanced understanding about that. See, I have used this word understanding. I shall come to that little later, but it is a thorough analytical understanding of an event, a thorough in-depth analytical ability to visualize what is contained in an event, in an entity, in an object. Okay, that is what is a deep learning. I just give a very simple example. Look at this example. Even in primary school days, we were taught about Chakravarti Ashoka. Even in primary school days, we used to know who is Ashoka, and stories of Chanakya was also told to us. The stories of Chanakya were also told to us. Therefore, we had somehow known about Ashoka. It is a sort of very high level or very superficial level or at a very macro level about the contributions of Ashoka. Then possibly in the middle school when we came, then we might have had some more chapters about Ashoka, some more chapters about Chanakya, some more details. So we got some more aspects, some more added dimensions, added more information into that. Okay, And then we went to from Ashoka. Then again we went to high school. Even in high school, we started learning about Ashoka. So high school in history, we might have had one full chapter on Ashoka. Then again, those who took history, even in +2, they might have devoted upon learning on Ashoka. Those who continued to take history at BA level would surely be doing on Ashoka in much better way. And then those would have taken Ashoka as a special study in MA would do it in much bigger way. And there are people who might have worked on PhD on Ashoka, Ashokan dynasty, Ashokan rule, etc., etc. So this is the graded way of learning about Ashoka. What are we doing? We are learning about Ashoka. We are extracting more and more details about Ashoka all through. This is what is the concept of deep learning. And then the machine learning is ability like human being would learn. See, we need this graded data which shall excite our learning, excite our inferencing mechanism, excite our thinking ability, and excite our decision making ability. Thinking ability, decision ability, and then taking the crucial decision about it, and then taking the right steps towards that. These are all the outcome of the learning later. So this part, if we are able to simulate on the machine, it is machine learning. So both deep learning is a method of extracting the information, extracting the data or information, and then deep learning. From deep learning, we will get into machine learning. Yes. Tell me.
Sir.
Yes.
Shall I interrupt?
Yes.
Sir, PPT then, sir.
But
it is not shared.
I shall come back to that. I shall come back to that. Okay.
Okay.
All right. Okay.
Okay. Thank you, sir.
Okay. So from deep learning, we have got to transit to machine learning. So deep learning and machine learning will become integrated part of entire process of pattern recognition. That is what we have got to understand. And look at your the banner brought out by Dr. Shekar and team. The banner shows both left part of the brain and the right part of the brain. And one part of the brain is touched by human hand and another part of the brain is touched by machine hand, which also should be able to tell you total automation is possibly difficult even for the days to come. So interaction of both human hand and machine hand is necessary in the process of entire learning process. It has got to be learning process, and learning leads to, I am specifically avoiding one particular word which I shall introduce now in the learning process. But interestingly, this human computer interaction has got to be properly understood. That has got to be understood. Without human computer interaction, the whole process cannot become totally be automatable. So automation of entire process is still a far reality to be realized later. There has got to be some portion which requires instinct, instantaneous, natural intelligence intervention of very instantaneous natural intelligence. If we can raise the level of the machine to exhibit this natural intelligence and instantaneous decision making based on the natural intelligence, then that is possibly the excellent end point of machine learning. But this instantaneous application of natural intelligence is because of the most important component called perfection in understanding, experience in the understanding the situation. So most important is how well have we understood. So understanding is the component which is of utmost priority. Naturally, understanding requires a lot of learning. Not only it is learning, it also requires learning from the experience, experiential learning. All right. So people may call it as reinforced learning. People may call it as repeated learning. People may call it as some different, whatever the different names. And I'm sure all experts who have spoken till now have spoken in different directions of learning. Somebody must have spoken on subdomain learning. Somebody must have spoken on high-ended supervised learning. Somebody might have spoken on quasi-supervised learning. Whatever it is, ultimately learning plus experience, learning from the experience and assimilating, inculcating and inbuilding, that is understanding. Understanding is not a documentation. It is an informal documentation which has already been made by the brain, and this informal documentation is not stored in any memory, but somewhere it is assessed, somewhere it is accessed easily at a point required, and that too at that instant of time. That has got to happen. Can we elevate the machine? Can we tell whether the machine which has learned the situation also has been able to understand the situation? Has machine understanding become possible? Has it become possible? That is what we have got to think. Probably next research in machine learning would be ability to see that machine has understood like a human being would have understood the situation. Machine understanding is entirely the advanced concept. It is at an imagination level. Now that has got to be realized whether machine can understand. I will give you another simple example. When some answer is given to you, or when there is some response for any question, you would carefully hear that, or you will carefully read that, and then understand that. And then after understanding, if it is an answer written by a student, you will carefully read it, assuming that our teachers would read the answer. Otherwise, if they just look at only other dimensions, other parameters like length of the answer, breadth of the answer, and superficial features which are visible in the answer, whether a diagram is put, whether an equation is available over there, or whether some word is highlighted, these are all superficial features. If valuation is done on feature extraction, then that is a different issue. But if carefully I read, after carefully reading, like a PhD thesis, carefully I read, after carefully reading, I try to understand the whole content comprehensively. Then close my eyes and decide to what level the PhD thesis has reached. That is what is understanding. If my machine can do that, it is a wonderful thing. Now, automation of valuation has been done, has been achieved, is being tried very seriously. But in the automation of valuation, am I sure that the machine which has read the answer has understood the answer, and after understanding that answer, it has decided to put 6 marks out of 10 marks, or 7.2 marks out of 10 marks, or 7.8 marks out of 10 marks, or is it based on the features? So we still do not really understand the difference. We still have not understood whether the machine is able to understand, because our whole purpose has not been able to visualize, has not been able to see whether the machine has understood or not. Therefore, at the end of this session, you should be more thinking toward this progressive idea of making the machine understand, which is beyond machine learning and beyond deep learning. So deep learning is associated with approximately with feature extraction of the pattern recognition part. Machine learning is the next part, which is recognition part, So deep learning and machine learning, both are very interesting. And again, I recall that picture which has been given by in the banner, that one machine hand is touching one part of the brain, and the human hand is touching the other part of the brain. But anyhow, the interesting point is it shows both the left brain and right brain. But I always see, when I see any picture of left brain and right brain, I totally get confused, And I always remember one statement. Please listen to this statement before I start sharing my videos, sharing my PPT, where I shall be discussing some of the presentations. Okay, so this first part of the theory, etc., we will not go through because we have already gone through 4 or 5 days of full of theory. And this interpretation, I was very sure nobody would have thought in that direction. Therefore, I wanted to take you to that level of what is called machine understanding, making the machine to understand. Now, coming back to the left brain and right brain, I always recall one very funny statement. Somebody told that nothing is right, nothing is going right in the left part of my brain, and nothing is left in the right part of the brain. So that is what has happened. I'm very sure Shekar and team have not made that to happen with your brain. Okay, so you remember, the statement is very funny. It tells that nothing is going right on the left part of the brain, and nothing is left in the right part of the brain now. Okay, so at the end of the day, this is what is the situation at the end of the course. Hope this is not going to be the situation. At least don't tell this when Shekar is going to conduct the test, and then tell we don't know anything. All right. Okay. Now I'm going to share the pictures now. Please check whether the sharing is proper or not. Okay. Is that visible?
Yes, sir.
Okay. I shall skip all the. Okay. Where is this? Okay. So I shall get into straight away some of the interesting applications. All right. In fact, the first part of this lecture was delivered at Mangalore only when Dr. Sharmila conducted a course. Now, second part, which I was not able to deliver it now, was the right material for valedictory, is going to be here. This example I had covered, so I shall not cover this example this time. But then I shall cover this particular example where it requires video analytics. It also requires machine learning. It also requires data extraction or deep learning or whatever it is. Okay, so look here. Whenever we go to library or whenever we see the material, today for some reasons we are so busy that we do not have the time to read through the material and understand the features or understand the entire content. We try to postpone understanding the content, but instantaneously take the action to input the data, to input the raw data. So the inputting the raw data, as you know, you would immediately do it. Now camera comes, the mobile camera comes so handy to interface with the input world and take the input data. So the input data is captured through the camera, and now you tell that the data is now available. Okay, that is good. Data is now available. So one part. Second part, you should understand that this can be a note on a file also. Like for example, you also would definitely do what has happened to my file. You would be asking, then when the file comes, can you tell me what is the status of the file? And you would definitely ask that clerk to take the picture of the noting by the vice chancellor or noting by the registrar. Take the picture and send it to me so that I will be knowing what has been happening. So when you take that picture of the noting by the vice chancellor or noting by the principal or whosoever, then you know that it is a handwritten note. It is not a machine printed note. It is a handwritten note. So only up to this point you just remember now. Okay. Now this is question number one. So the data is captured through a mobile camera. All right, and then the processing has got to be done next. Now we advance that note, the concept. When we take the picture, we take the entire picture of the page, which includes both the images present in the picture and also the text present in the picture. Is it all right? But only other problem is the orientation of your mobile camera. Based on the orientation, surely there are certain geometrical deformations in addition to the noise which is inherently possible from the source of the data. noise from the source of the data, noise at the mobile level, noise also due to holding of the mobile. All of them will cause a very noisy, which is geometrically deformed image on your mobile camera. All right. Okay. Now, if the page is too big, then we start moving the camera from one end to the other end. Now it becomes multiple instances of partial images, not one full image. It is partial images, or conversely, it can even be the video of a single text document. It's a video of the single text document. So now the next problem is naturally, as I said, that it is a holding direction, orientation. All these geometrical deformations could be possible. Now, from here, the very first question is how to reconstruct the data which would be like that of original data. Originality of the input can be retained. Can that be possible? Question number one. How to ensure that the fidelity of reproduction of the data is guaranteed? This is one question. And particularly that question is of great relevance if multiple exposures of the data is available, because single exposure could not be possible. And number two, other interesting and difficult problem is when it is handwritten data, right? When it is very much handwritten data, okay, the replication of handwritten image could become possible. The next part is now the feature extraction, reading this data. Okay, so when you go for reading, of course, printed data, you can easily, comfortably read. Good handwriting, you can comfortably read. But then can reading also be made automatic, which naturally requires some OCR. All right. So look at this. The OCR also now should get inside your mobile itself so that automatic reading can also become possible. All right. So when OCRing a handwritten document is really difficult, and particularly it will be very, very difficult because the notes that you put on any note sheet will not be in a straight line. It will be highly inclined. So all these corrections have got to be made. So whether automatic reading can become possible. Or the next question is, most interesting question is, whether the input is handwritten version, but the one which should be presented should be in a readable, neatly readable, machine printed machine printed document. Can that be possible? Can that instantaneously be possible? So naturally, whether the machine itself can understand that, and the machine, and after understanding that it is not readable, after understanding what has got to be done, can the machine itself take a decision and do all these activities and present? Still I am at the data level itself, little advanced information level itself, that whether it can reproduce the data or information in more understandable way. This is the first question. Naturally, here you have got to think how machine learning could be a very important way of solving this problem. If it is handwritten, then, and if it is very badly handwritten, then you can understand the meaning of the interesting meaning of deep learning also there. Okay, you will definitely understand how deep learning, at least two levels of learning or 3 levels of learning could be very necessary to convert a badly handwritten document into a machine printed type of document. Okay, right, all right. And in addition to that, all these geometrical understanding what sort of geometrical deformation has taken place, automatically understanding what sort of geometrical deformation has taken place, and automatically doing the counter geometrical corrections. Okay. Now, the advanced issue with this is the following, that you take up the document like Arabic document, then, and I also imagine that the entire document was not able to be pictured using only one exposure, but you need multiple exposure. in which direction this mobile has got to be moved. Or the mobile will be aligned. Will it move from right to left of the page or left to right of the page? Of course, if it is an offline recognition, then it does not make a big difference whether it is right to left or left to right. Even without the knowledge of the direction in which this document is generated, you can still reproduce the document. But if it is real-time recognition or online recognition, then this would matter a lot. Okay, there are scripts where lot more challenges are there. It is not only right to left and left to right, which happens normally with Arabic scripts and normally with all these Roman scripts, English scripts, Devanagari scripts, but with Chinese and Korean scripts, you also start writing from top to bottom. The writing is from top to bottom also, so we should take care of that. So the additional interesting problem is, similarly related problem is, can I have my mobile smart enough, intelligent enough to automatically understand and decipher the value of the note if I show that any part of the note, not here in this picture I am showing full part of the note, but it is not possible to always show the full part of the note, particularly when you get down from an auto rickshaw during the night time and there are no lights nearby. At that time, you would just pull out from your wallet or from your pocket some note, and you want to see how much, what is the value of the note that you are giving it to the auto rickshaw driver. And when the auto rickshaw driver gives back the change, you want to you cannot see it and count it. Therefore, you want your mobile to count it, but then you cannot hold the machine. You cannot make a scanning, a perfect scanning of the note. You cannot have a perfect view of the total view of the note. But then whichever the corner of the note visible to the camera should be able to decide that this is the 20 rupee note, this is 10 rupee note, this is 50 rupee note, 100 rupee note, from whatever the direction. It can be flipped side of the note or the other side of the note, where Mahatma Gandhi is visible or not visible, any portion of the note. Okay, can you be able to do that? And please see why here instantaneous deep learning is required. The note that will be handled from man to man would have gone through so much of spoiling. Note would have got so much of spoil. There are a lot of oil stains, lot of handwritten, lot of soiling, and then from this, it has got to filter out all this noise. It has got to eliminate all this noise automatically, instantaneously, and should be able to still get the signal content and decipher the value of the note. And note that one, added to all these external noises on the note like soiling, etc., others are geometrical deformation and visibility itself. The whole full note will not be visible. A part of the note is visible. Then imagine what type of learning is required by the machine to understand the whole content by the partial view of the total content. Very, very partial view of the total content, right? Or imagine like you will have only a very partial view. I will show only one finger of a beautiful, a handsome person or a beautiful lady, and looking at the finger, you should be able to tell who the person is. That is the type of problem you have got to solve. I am going to show only the forehead. Now people wear masks also. Therefore, the lips will not be visible. You will be able to see only forehead. And looking at the forehead, you should be able to decide that this is the person. And in the forehead, there may be enough, noisy corruption, soily or anything, whatever could, in addition to, in spite of all that, can you be able to recognize? This is the type of problem. So one, at the feature extraction, two, recognition, three, real-time application. All right. So text document problems are mostly offline recognition. We need not be worried about the real-time recognition as far as the present context is concerned. But however, there are requirements for real-time writing also. For example, when you are probably, if there is a writing interface provided for making the railway reservation or voice interface provided for making the railway reservation, let us say, particularly let us assume writing interface. When I am writing itself, the machine also should be able to understand that your travel is going to be from, let us say, from Mangalore, or let us say from Mysore, and you intend taking up the travel to Bhubaneswar. It has got to understand as and when the person is writing. It is instantaneous real-time response is also required if writing interface is provided, because some of us would be more comfortable in writing the response rather than entering it through the keyboard. Okay, all right. So that is the interesting problem which I wanted to illustrate. But this is only still at the data level. Later, it is not just the recognition. Later, it has got to do a lot of things like in text document, it has got to automatically extract some particular word keywords, automatically, separate the lines, automatically do the line separation, segmentation it has got to do, and it has got to intelligently understand the date of the letter. It has got to intelligently understand who has signed this letter, and it has got to intelligently understand what is the content of the letter. Now, two things. Number one, just extracting the content is different, and since you want your computer, your processor, the mobile itself to read that letter and give the summary of the letter in one sentence or in two sentences. Okay, give the summary like a person who would have understood the content would like to tell about, like my personal secretary who will go through the entire letter and tell me about the important crux of the letter. Like, sir, it requires immediate attention of yours, sir. Sir, it requires, this is a letter from a ministry, sir. They want to know this, and this is what, this type of interaction, can it be done by my mobile processor itself? All right, I'm adding the word processor also into the mobile, processing also into the mobile. Okay, this is where advanced machine learning, more so machine understanding, becomes important. Okay, all right. So here is another interesting problem. So when we give a page, naturally it is a tendency of any human being, like teachers particularly, even students, they make a lot of annotation on the page itself. We do a lot of annotation on the page. Okay. Now, let us assume the problem of removing all these annotations automatically. Well, here the problem is very simple. The problem is simple because I have taken up a problem of a printed page, and annotations are made by pencil or pen, and it is handwritten annotation. So naturally, the learning of the printed page versus the noise or versus this extra writing can be learned from the document itself, from that document image itself. Then I should be able to remove all this. I should be able to remove all this. But even then, you can see that there can be some noise left out, like here. This was not able to be removed fully, and this was not able to be removed fully, because our focus was here on the ability to remove whatever was written outside the text portion. So then you now can think that you would have made correction here only, you would have made correction inside, and then the machine has got to understand. Now, the most important question is, I would have made all such correction and I would input it. Can the machine automatically edit the whole document and reproduce the document, new document, with all these corrections incorporated into the document? I tell you the interesting application little later. Now, what's going to happen? I shall come to that little later. Okay. So these are the noise removal. Okay. Now I shall take up another interesting problem. Now the question is, without reading these two documents, would you be able to tell that these two documents are equivalent? Can I test the equivalence between these two documents? So when you look at the document superficially, you can feel that these two documents could be one and the same. because the geometrical organization or the structural organization of the two documents appear to be very similar. You can see the paragraphs are similar, etc. But you cannot do reading. Number one, reading should not be done. OCR cannot be applied. That is the objective of the problem. Number two, even if you wish to read, you cannot read because this is not at all readable. See, the visibility of the document is so poor, and many contents are some places it is so much worn out that you cannot even read the content. Under such circumstances, can you find out the equivalence of these two documents, and then throw out one of the document if it is redundant, okay, which is highly noisy and redundant, can you throw out and retain only this copy? So that's the type of problem. Well, when you take up this problem, I shall give you a little more advanced problem like this. This is a scaled down version of the document, and this is a normal size of the document, let us assume. Even under a scaled down version like this, can you be able to establish the equivalence of the document? Okay, right? So when the two documents are very good, equal in equal in all respects, quality, etc., then probably telling the equivalence could be very easy. Of course, you need to use document image analytics, a document image comparison. I shall not get into that, but then I'm just quoting the problems, right? So we had come out with one method of converting every content into signals. Okay, this document also into a set of signals, and this document also into a set of signals, and then we started seeing whether the equivalence of the two signals can be established. Naturally, the document itself contains so many lines, and every physical line is composed of so many pixel lines, and all these lines converted into signals would definitely become a very big data problem, and we have got to circumvent the big data issue, and that becomes a very big data machine learning under big data condition. So that's the problem is very interesting. I am not going to give any solution to any problem now, because my motivation is only my requirement is only to motivate you to think that there are plenty of problems which still require your attention to solve the problem. All right. Okay. So now I'm just extending this problem. So the question is now to find out who has copied and copied answers. So here is a problem. Here is the original author, the first author. The first author in the examination surely makes some research while writing the answer for a very difficult question. So he will strike out, he will strike off and then replace it and then write and then he will do. But the person who is copying is more intelligent. He copies whatever is struck off by him. Why should he copy that? He will not copy that at all. So you have got to tell that this is a copied version of this answer, and the original author is this. See, it is not just only telling who has copied from whom. You have got to also identify which is the source answer book and which is the copied answer book, because the person who has copied should be punished. And of course, the source also should be punished, provided you can find out that he has voluntarily allowed the copying to happen. But then this is the interesting problem. Now you can see here the next alternative is this. The page length here, the page dimension here is different. Therefore, he has also copied from here, but the number of lines will be more here. Again, the question is not by reading. I cannot apply any OCR. I don't apply any OCR for the simple reason, handwritings, badly written handwritings will not respond to OCR. OCRs are very difficult to respond to very badly written handwriting. Two, the answers can be at multilingual level, at multi-script level. Any natural answer could be in multi-script or multilingual level, in which case a single OCR cannot work. Three, still OCRs are not being possible for even all Indian languages. Even with great difficulty, we have got now good OCRs for Tamil and for Kannada. For Malayalam also some good OCRs have been reported, but then not excellent OCRs are available for handwritten Kannada text document. Okay, so if it is multi-lined also, I should be able to tell that this document, the copied answer book, copied answer is this, the original source is this. Okay, right? And naturally, original source will have many original, creations, and then strike off, and then replacement. Everything would be done, and intelligent copier will not copy all those. Okay. So now, what can be seen then? Now, how to establish one equivalence? Naturally, we depend upon the sequence. The total number of words here should be same as total number of words here, right? And the relative sizes of the words, there shall be correlation between the sequence of the sizes. Okay, so here rows, you know that rows approximately occupy so much of space, whether it is written by a very bad handwriting or a good handwriting or whatever is the handwriting. This is the type of the size. You quantify the size in any multi-dimensional way: length, breadth, the area, total pixels occupied within that, not occupied within that, whatever the number of features. Then you establish the correlation between this sequence. Sequence is also important. After a big box is a very small box. After a very small box is a very, very small box. And after this very, very small box, immediately comes a very big box, and then equally in size box, like that. This is simple English, and you quantify it, therefore it becomes a sequence. And with that sequence is a multi-dimensional, multi-feature sequence. You do the correlation analysis between these multi-dimensional sequences, and then you establish whether this is equivalent to this document or not. Okay. Naturally, you can always come out with the counter example. You fix up the same, same sizes, and then you can always find a word which can fit into this, but it is not at all a rose. It can be a pose. Okay, it need not be a flower. It can be a toilet. It can be a tailor also. All right. So you can always bring in some new word. Okay, or it can even be badly written follower also, right? So you can always tell that it might not work, but then this is under suspension. This is under the suspicion that this is a copied document, therefore it might work. Okay, but then a lot more work can be always taken up. Okay, all right. So the interesting part of this is the automation of your whole answer book evaluation. In fact, when I take up this question, you should understand that any student will not write the answer in the same sequence as would be expected in the question paper. So here is one example where I have shown a student would have started writing the answer for question number 5A. Then he realizes that he does not know the answer for question number 5B. For some reason, he misses it here. And then he writes the answer for 5C. And he has left some space here, hopefully with the hope that he might continue to write that 5B, or he may bring in the answer for 5B here. It might be with some hope he might have left this space. And then after 5C, he went to question number 2, and he could not answer 2A, but he thought he can answer 2B. And then suddenly he felt that he can answer 5B. But then this is not what is really wanted, appreciated by an examiner if you think automation has got to be done. Okay. So the very first step in automating is naturally pulling out the entire answer book, and then let us call it as de-stitching the answer book, because answer book would be a stitched answer book. You de-stitch the answer book and then re-stitch the answer book by concatenating all the answers in a proper sequence. Only this part, I am not going for any automation in the valuation part. Maybe in the next part, if time permits, I would come to that. Otherwise, I am just sticking on to this particular part of how to arrange the entire answer book in the sequence of what the question paper would expect, so that an examiner would beforehand understand that this candidate has answered these questions and this candidate has not answered these questions. There is no point in searching the answer book again and again to look into the possibility of this question being answered. And if some particular part is 5B is missing or 5D is missing, it is surely missing. You need not search the entire answer book again and again for hunting for the 5D. That you need not do. So that's the type of activity that we have got to do. But even here, I shall assume that the question numbers are at least been written properly by the candidate, question number, that I shall assume. And I shall also assume that the question numbers have been written on the other side of the margin, whereas there are a lot of intelligent students who write the question number after the margin also. They are all very difficult situation. Even under such situation also, what is the deep learning that you can adapt to estimate that this is the answer for this possible question and then decide the question number, even if the question number is not written by the candidate. Or some candidates are so lousy that instead of writing the question number properly, they will write a number like 1 if they have answered that question as 1. Although it is question number 5A, he will write it as 1A because he has answered it first. So all these combinations, all these problems are there. Naturally, the answer is basically whether the machine can understand, not learning, beyond learning, whether the machine can understand like an examiner would understand. So can that be ensured that machine has understood it and has done it, so that whatever the machine has done is 100% correct. Okay, so here, therefore, assuming that the question numbers are written on the other side of the margin, so my case of interest becomes this particular area now. First, this particular area. So only I shall segment that particular area, and based on the segment, as I said, I shall do the de-stitching. De-stitching is segmentation of the answer, segmentation of every answer component, and then as I see here, 5A is written here, and somewhere else is the next continued answer. Then look here, this answer particularly, a part of this answer also has been in the next page. So I shall de-stitch and then re-stitch both these answers together. Re-stitch both these answers together so that it becomes one full content for the examiner. Okay, so can that be possible? So you definitely think this problem. Then, we want to introduce anyway, the valuation could become possible anyway. It should not be central valuation. It is not necessary that the teacher should be brought in and caged in a place called central valuation, and then he has got to go through the answer books. Can we make it anywhere? Sure, you can make it anywhere. And can it be made even smart devices like mobile readable answers? Yes, it can be possible. But one more step we are trying to, I'm trying to pose the problem, because these answers are now available. Can you compress these answers so that compressed file can be easily transmitted? How it has got to be transmitted? Should we employ the cloud? Should the user access the answer from the cloud? These are all different technology aspect, different software architecture. We shall not get worried about it. Now, I am just posing this problem that can I compress the answer book, and can the person who is reading the answer would be able to read only that particular line? Or in other words, the decompression algorithm would work only for that region where the eyes are focusing on. That is all. Can I just decompress only that particular portion, so that decompression is almost a sort of piecemeal decompression could be done, not necessary to decompress the entire document, and then it can be awarded. If it is answer book like history, or answer book like a descriptive answer book like history, or descriptive answer book without any mathematical equation, without any mathematical diagram, it is like English or languages, etc. Can the machine itself read the answer for me, for the evaluator. So like this, I want to relax, I want to listen to the answer book, and then tell the marks. After it will tell, now I am presenting the answer for question number 6A. The answer is like this. It should be able to read, and then the examiner will automatically tell, after listening to the answer, he will tell, okay, 5 marks out of 8 marks, or 4.5 marks out of 8 marks. That is what he would tell. So if reading is not preferred, can hearing be possible? Yes, it can be possible. You have got to take it up as a whole big project, and you can see how many issues are there in this problem. Although I have missed several other architectural details, several other software architecture details I have purposefully missed, but still there are many interesting problems associated with that. Okay. All right. So most important here is, I told it is compressed domain, and I told it is handwritten answers, compressed domain, and if the machine has got to read automatically, even if the machine has got to read it automatically, it has got to do this line segmentation properly. Note that the answers are normally on a unruled answer book, in an unruled answer book, and the students will not have the same patience, and he will not be similarly sensitive as he would be at the beginning of the examination. When you go towards the end pages, the handwriting would become so horrible, and it will be so much overlapping, and after that it is now compressed, and the compressed domain, without decompressing, can I draw these lines of segmentation without decompressing? Remember that. Can I draw these lines of segmentation? That's the challenging work, because the answer has got to be, as I said, decompression shall be done line wise. And which line I have got to do? The line which most probably the examiner is going to read now. That is the place where the partial decompression has got to be done. Therefore, all these lines have got to have been pre-segmented, and for this pre-segmentation, that has got to be done in the compressed domain itself. Can that be possible? Can you achieve that? Okay. All right. You should be able to do that. But what is shown is in the uncompressed document. But this has got to happen in the compressed domain. The segmentation of the handwritten answers, line-wise segmentation, has got to happen in the compressed domain. Okay. All right. I shall take up another intelligent problem. This is called intelligent secretarial support. Okay. So now today I can dictate whatever as a director. I can use my dictaphone and then dictate whatever I want to dictate. So the dictaphone files could be input, or my secretary himself would note it down in the shorthand. That could be available, or it can be both, because my secretary would think that even putting on the dictaphone is also useful, because he might have missed, or he might have heard something improperly. Then can the inputs be both of dictaphone and Pitman? So it is multiple source. Data fusion has got to be done from multiple sources. So that is one other interesting problem. But anyhow, the input can be either from a dictaphone or from a Pitman shorthand. Then we have got to do the word substitution. See, these are all. Dictaphone is in the signal form. All right. You have got to choose that signal. Let us assume that word signal is segmented and identified, properly identified. This is quite a lot of work. And then even here in the Pitman shorthand, let me assume that I have isolated the word, and then that part which is in the pictorial form or which is in the signal form has got to be substituted by the proper word. Word substitution has got to be done. For the word substitution, naturally, you need to have the domain knowledge base. For example, if it is a petroleum company and the boss is dealing with only petroleum activities, the type of domain knowledge base is entirely different from that of the happening in a vice chancellor's office, and from that of the happening which is happening in the share market business. So there should be domain knowledge base which has got to be developed, and that specific domain, specific dictionary will be able to do a very good word substitution. So this is the intelligent part of it in designing, and naturally the domain is important. In any computer science activity, in any information technology activity, although we tell that the performance has got to be akin to that of human being, please note that the efficiency of bringing the performance as close as that of human being can be possible only in a particular domain, and provided that particular domain is properly modeled. Okay, so that is then there can be, this is signal equivalent, there can be very big confusion, like if I have dictated week, whether it is week or weak, this is the phonetic problem. So there has got to be a phonetic knowledge base also, there has got to be a phonetic dictionary also. So domain dictionary, phonetic dictionary will make the word substitution. Okay, because these are not in the text base. This is in the signal form, this is in the shorthand form. Therefore, the text visibility will not be there, script visibility will not be there, and I got to bring it to a script form. And so they got these two. One is domain dictionary will make the replace substitution very quick, and phonetic dictionary will resolve the phonetic issues. Okay, right. Then there can be other problems like homophone substitution, for which homophone knowledge base is required. But then the next is that text correction is done, and this text correction, I might see it is spoken language, so it might not be grammatically correct. Can I also have a grammar knowledge base and do the correction? Like we have now been seeing, when you start writing the email, then automatically you can see a grammar support system, a grammar expert system also helps you. So please add the here, there is a mismatch of tense, it adds that. But still finally it is human computer interaction only, because you have got to choose it. But here, can it be automatically be done? So the text correction with the grammar knowledge base, can it be done? See, in the dictation, unless I have told next paragraph, or you bring it to the previous paragraph or the next paragraph, or you change the paragraph, it is a continuous composition. So can there be a composition input and the text organization, can it be done as envisaged by the person who has created the text, as dreamt by the person who has created the text? So can there be a composition knowledge base? So there is a grammar knowledge base to have the correct formulation, and there is a composition knowledge base which provides the proper text organization. So if all of them could be realized, then I have a very wonderful deliverable text file. So that is an intelligent secretarial support. See here again, the dictaphone is in a signal level, signal processing level, whereas Pitman shorthand, when it is scanned, it is an image. Okay, it's a document image. So image activities have got to happen. Here, dictaphone is from signal. So these two inputs have got to be fused. All right, one is from signal, another is from image level. Okay, all right, that's the interesting problem. So you can see what are the intelligent components to be created. Naturally, one man cannot do it. It's a teamwork. Can a team take it up? In fact, if a team can take it up and can identify the real original contributions of the team, surely this can become a material for at least 2 or 3 concurrent PhD. 3 PhD candidates or 2 PhD candidates can start the work together, end the work together successfully, and come out with a very, very powerful product, not a product which just can work. It has got to be a very intelligent component. Probably the way I want a very understandable boss. I want to employ understandable boss. I want to employ an understandable assistant. Like that, can this secretarial support be an understandable assistant, which should not only be intelligent, should be smart enough also to understand the boss's requirements. Okay, that's the okay. Similarly, I think I shall. Yeah. Okay, I shall speak about it. this is the question of intelligent OCR. OCR particularly for handwritten text. Okay, so noise-ridden text, text containing struck-off words, text containing artistic words. So then there are a lot of plenty of gaps, recognition of the gaps, and understanding the content with the context with the neighborhood. The plenty of gaps is because ordinary OCR cannot decipher the struck-off words, cannot decipher some of words. So the gaps are not recognized portions. How do you fill up those gaps? Okay, and to fill up the gaps, you have got to understand the neighborhood and then assess, understand. That is most important. And again, as I said in the previous application, can I have a domain knowledge? Can I have a domain dictionary? Can I make gap salvaging here? And then can I generate a OCR output? So this is important. Here, text containing struck-off words. I want my OCR to be more intelligent also. When people have struck-off words, they would have also written what word has got to replace it there also, either above it or below it or next to it. Only most of the time we people write it. Then can my OCR intelligently make that substitution also in place of that struck off word and then fill up that gap also? So this is what an advanced OCR or a machine learnable OCR could be possible. Okay, naturally here deep learning also becomes necessary here. Okay, all right. Okay, here is another interesting problem. Sharmila, you can tell me to stop at any point. Okay, there are a lot of problems.
Yes, sir. Yes, sure, sir.
Okay, can I continue for some more time?
Yes, sir. Another 5 minutes.
All right, here is one more problem. This is the general problem of filling up the application forms. Normally, when the hardcore application forms are given today, we know that almost all fillings also have to be done on the machine itself, interactively into Google Forms. But still, there are forms where we have got to fill by hand. Here, when we fill up by hand, the question part, which is pre-printed part, is same, is similar for all, and our response part will be different. Is it all right? So let me call this as variant part, and all these printed as invariant form. So the invariant part, because it is a priori available, machine would have already understood that. Definitely machine would have understood that. This variant part, machine not only has got to understand, but machine has got to also decipher that. Okay. Now, how many types of handwritings can you train for the system now? You can train some limited handwriting. You may train the system with 100 different handwriting, 200 different handwriting, maybe 1,000 different handwriting, but still there shall be a lot of variation. As many writers are there, so many handwriting variations would be there. And number one. Number two, you might have trained the responses to be given, let us say in English, in Roman script. But if somebody has responded it in Devanagari script, or somebody has responded it in Tamil script, or somebody has responded it in Kannada script, okay, so the additional other training set have not been not available. Can I use the knowledge of my understanding about the different types of handwriting, and can I still apply it to understand Kannada? This is what is called transfer learning. Can transfer learning be possible over here? So these are the interesting issues. So the interesting issues is automatically understanding the variant part and automatically updating the database with the variant part, not in the handwriting form, but in the regular text, regular text in regular font. Okay, so that the machine can understand later and process it later. Okay, this is the type of problem that you have got to think of. Okay, now I shall skip this problem because that's. I skipped this problem. I also skipped this problem. I shall come to one interesting problem. Look, the query is, I want a picture of dog with cat. Query is a text query, a voice query, or whatever. I want all the pictures. I'm giving that to the Google image search engine. The Google image search engine should search all the images where dog is present with cat. Now look at, when I presented this query, these are the answers that the system generated. So this is dog with cat. Okay. All right. Let us give the benefit of doubt. The proper answer is this and this, because I have asked for a singular dog with a singular cat. Okay. Benefit of doubt can be given to this, though it is multiple dogs and multiple cats. Okay. It is okay. Still query, it responds to the query. Then look here. This is a wrong retrieval. All right. It's a very wrong retrieval. Both of them are cats here. All right. So it has wrongly retrieved it. That's a wrong retrieval. So some understanding, learning is still not proper, is still not correct. Or the learning or the query, interpretation of the query itself is still incorrect. So it is dog with the cat. So it might have made dog or cat. So that with has been replaced as or plus. So the type of interpretation done itself is incomplete. So even here, there could be a fault with learning, or in the retrieval system also there could be a fault with learning. Okay. So this is also incorrect. Again, it's only dog. Look here. This is ununderstandable. The query is dog with cat. Why did this lady come out of the query? Why this lady has got to be there? So if this is a dog, then this lady must be a cat only, dog with cat. So these are all the incorrect interpretations still made by the machine. Now this has got to be made. All that I just wanted to tell you is that there is a never-ending scope for this field of learning. Now I added one more dimension. Can you make the machine understand along with the learning? Okay. So I shall stop at this point. Of course, this is a very interesting problem. I shall stop at this point. Okay.